But anyways, for questions like these, I mean, let's see where BCT is first, actually. Well, let me just copy this sketch because this whole thing of scrolling up and down, it's not very productive. It's not very conducive either. So let's see. So with all this information, like whatever we worked out, we'll have to keep it in mind. It might help us for this question. Oh, excuse me. My phone is ringing, but I cannot answer it right now. Ish. But it's
sure it's not an emergency? I mean, I don't mind.
thank you, ma'am. Thank you. Moving on. Anyway, so what did they want us to do here? They said write down the length of the radius of the circle passing through BCT. So one thing we have already worked out is the length of all these lines here, 6 square root of 5, and then this one is like 3 square root of 5. To be honest, these answers, they're a bit scary to look at because this one is bigger than that one, but then according to the sketch, this one should be bigger than this one. Yeah, it just looks a bit disheartening, just a little bit. But it is what it is. This one was like 10, coordinate 19. And then this was 4 and 7, right?
Yes.
Ooh, what does a person say when someone hicks up? Should they say bless you, or they just keep quiet? They just keep quiet and be like, okay, let's pretend that did not just happen. It was just a random sound. We shall pretend we didn't
That's
hear
actually exactly what we do. They treat it like a random sound.
Really? But it's just like, just doesn't feel normal, it's like, I must say something. I must say something, what if the person just, and then now it's like, it's because you didn't say bless you. It's your fault. Right, never mind. So we clearly need to reread the question because after putting in all this information, we need to see what we can do. They say write down the length of the radius of the circle passing through B, C, and T. So the fortunate thing is, if you're going to have a circle passing through B, C, and T, you have to be a bit awake to get why they are talking about a circle passing through B, C, and T. A circle passing through BCT, I was drawing a circle there, imagine. Yes, like that did not come out very well. So a circle passing through BCT would look something like this, you see. Now, the idea with this circle is that inside it, you have a triangle where that triangle has a 90-degree angle. So anytime you have a right angle triangle that is touching all sides of a circle, it means that let me just write it out. This is something that you probably know or maybe forgot, but it's not like gonna be 100% new. So you have a circle here, right? As long as B, T, and C are points that the circle touches, we can already see angle T is 90. And if angle T is 90, it means that BC is the diameter. It's more like a law. As long as BC is the diameter. Oh snap. Sorry. I'm sorry. Over and over again. I'll just have to finish and then call them later.
Hey.
Anyways, so the one thing we mentioned here was that if this is a circle, right, that passes through B, C, and T, the one thing to remember is that this is not just a random circle, and this is also not just a random triangle, because as long as this is specifically a right angle triangle, it means that BC is the diameter of the circle. Anytime you have a circle where the right angle triangle is inside the circle and all sides of the triangle are touching the circle, it means that the angle, or rather the side that is being subtended by a 90-degree angle is going to be the side that's the diameter, you see. So I don't know if that makes sense to say, if you ever have a triangle, right, inside a circle, if you have a 90-degree angle here, right? The side opposite the 90-degree angle is always the diameter. That's a law.
No, that makes sense.
Yeah. So that's one thing you always want to remember, you see, because it's like a Euclidean geometry law. You know, whenever it is that we're going to work on Euclidean geometry, this is going to make a bit more sense. So let me remove this arrow so that it doesn't make things a bit weird. So as long as BC is the diameter, automatically it means that we know what the center is. It's going to be somewhere here. Wherever the center is, it's going to be the middle of BC. So, I mean, like if they want the length of the radius, we might as well just get BC, of which we have BC. I'm like, BC is just 15. And half of 15 is going to be the radius. You can imagine that's why this is just a 2-mark question, because it's 2 marks coming from us just knowing our theory, of which the one piece of theory we would need to identify is that, okay, wait a minute. As long as the circle passes through BCT, it means that the line BC is the diameter, which is 15, meaning that the radius would automatically need to be half of 15 because 15 is the diameter. Cool.
Okay.
Nice.
I get it.
Nice. Is okay, madam. Is okay. So that was that for that specific question.